Hello everyone, so in this video we are going to talk about text embedding in Mediapipe. So basically, as you can see over here, you have a piece of text and we figure out a way to convert it into a fixed sized vector. So something like image embedding, but a little bit better than that, because there are some problems that only text have. For example, the text can be of any length and so on and so forth. So Mediapipe text embedder tasks let you create a numeric representation of text data to capture its semantic meaning. Okay, so after that, what it can do is basically you will have two pieces of text, and then you will use mathematical comparison techniques such as cosine similarity to figure out whether they are close enough or not, or whether they are same. So whenever there is a sentence, and the sentence 1 and sentence 2, and let's say they are talking about the same topic, then you are going to have a higher score. But they are talking about, if they are talking about different topics, then it is going to be, the similarity is going to be less. However, this is not sentiment analysis, because even if the sentiment is completely opposite, let's say I like a movie, or that's sentence 1, and the sentence 2 is I didn't like the movie. In both these cases, even though the sentiment is completely opposite, the similarity is quite high, because both of them are talking about movies, going for movies. So the cosine similarity is going to be very, very high in this case. Again, I have taken the code from here, the Python code, and then I have modified it a little bit so that we can use it for our use case. Okay, so basic configuration stuff we always leave it, so it's not that important. The recommended model, will directly go to the model. So the model is over here. It's a dual encoder architecture, not very I mean, it was trained on question answer data sets, so it can be used. Okay, so let's say, for example, it's a charming and often affecting journey, and what a great and fantastic trip. So obviously these two are talking about a trip, a journey, so it's going to have a high score. The second example is I like my phone, and the first sentence here is I like my phone, the second sentence is I hate my phone. Even though they are completely opposite, they are talking about the same thing, that is phone, which means that the similarity is going to be high. But the third case, this restaurant has a great gimmick, and we need to double check the details of our plan. These two are completely unrelated, and so the the cosine similarity is going to be going to be low, and that is what is explained over here. Okay, so let's go and look into the code. Okay, so as usual, what you do is you run to say Mediapipe. So you install Mediapipe. So pip install -q. Again, the code is going to be in the GitHub, and the link is going to be in the description, so don't have to worry. You can definitely go and download the notebook from there, and this is what you need to copy and paste. So this is where your model is, and this is how you get it. Okay, after that, again, you do mediapipe.tasks. From mediapipe.tasks you import Python, because that is what we will be doing. And then from mediapipe.tasks.python import text. Why text? Because we are going to do a text embedder kind of text, or a question or a problem related to text processing. So that is what we are going to do over here. Okay, then obviously the model is downloaded. After this particular line, the model is there, and you can go over here, you can copy path, and then figure out, and then over here you can paste it. So this will work. Okay, then this becomes model asset path, and then we are getting here the base options, and then you can create your option from here by text embedder option, and then pass it as a base option. Okay, once you are done with that, you just have to instantiate this class. Then what your first text is going to be, the food was delicious, and second text is we have homework today. So this should give a low score. Okay, so you calculate the embedding. So what you say is embedding.embed, embedder.embed, and again embedder.embed, you get this embedding. And then finally you find the similarity, that is text.textembedder.cosine similarity, and then you pass the two embeddings. So I think you can also get the embeddings if you want. So let's say if you have, let's say, some kind of a work, what you can do, you can you want to do something else with this, so you can do over here, and you can see there are some numbers. Let's see the shape of this, or what this is, by the way, and we'll see what it is. Okay, so we'll do a dir on that, and basically then we'll try to figure out how to get this particular I think you can just do embedding, or let me just do a dir. Okay, so let me do a dir and then figure out But before that, I just want to complete this one. Okay, so you did a similarity over here. You took the embeddings of the first embedding is over here, embedding of 0, and then you did a second embedding over here, and then you passed it into a text embedded dot cosine similarity. You found the similarity over here, and then you printed the similarity. You got not very bad, but again 0.58. So you have to the similarity is low, but not very low, even though it should have been very low. I think if you give a longer sentence over here in both of them, I think more context will be captured. So again, you can see there is embedding. Okay, so we'll try to do that. So I'll go over here, first embedding dot embedding dot embeddings dot a dot 0. So after that, let me go and paste, and then just write embedding embedding. Let's see what we get. So we have again got those numbers. Hopefully this is a numpy array so that I can basically claim victory. Yeah, it looks like a numpy array, so I'm going to find the shape, and if I'm able to do that, it means it's a numpy array, and the shape is 512, typical of the classifier. Okay, so these are standard numbers 512. So you can use this particular output, this vector, in doing other things. If you want, you can you can think of contrastive learning and so many other things. So I hope you like the video. If you like, please like and subscribe. Thank you very much, and bye.